Here's a new topic, that is curl of a vector and the irrotational vector. Let's see what is a curl of a vector. So that f bar is equals to f1 I bar plus f2 j bar plus f3 k bar is a vector differential function. Then the curl f bar is denoted by curl f bar is equals to I bar cross dou f bar by dou x plus j bar cross dou f bar by dou y plus k bar cross dou f bar by dou z. So here f bar plus f1 I bar plus f2 j bar plus f3 k bar is a vector differential function, nothing but because it is having I, j, k vectors in the equation, and we write the curl of a vector as in this way. So from this all we can write it as I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z and cross f bar. So when we multiply this, we get the same here. And here I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z cross f bar can be written as f1 I bar plus f2 j bar plus f3 k bar. So we know that I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z can be written as del, and cross this is the f bar. So curl f bar can be written as del cross f bar, and that equals to the determinant of I bar j bar k bar and dou by dou x, dou by dou y, dou by dou z, and here are the I bar coefficient and j bar coefficient and the k bar coefficient, that is f1, f2, f3. When we find the determinant of this, we will get the curl of a vector which is del cross f bar. And let's see what is a irrotational vector. A vector f bar is said to be irrotational vector if curl f bar is equals to 0 or del cross f bar is equals to 0. So when the curl of a vector that is f bar is 0, then we say that the f bar vector is irrotational vector. And here we have the note point, that is a scalar function pi of x comma y comma z such that f bar is grade pi, and then pi is called as a scalar potential function of f bar. So here we are taking a scalar function, that is pi. It means it is a scalar point function which consists of only x, y, z variables, and it doesn't consist of any vectors like I, j and k. So we call it as scalar point function. And when the f bar is grade pi, so f bar is nothing but the grade pi, at that time the pi, which is a scalar point function, is called as the scalar potential function of the vector f bar. So that is, if f bar is equals to grade pi, then curl f bar is always 0. That is, when you substitute the f bar, that is grade pi, so we get curl of grade pi is always 0. This is a note point here. Let's solve few of the important questions on the curl of a vector. Here is the first question, that is, if f bar is x I bar minus y square j bar plus z cube k bar, and then we have to find out the curl of a vector f bar. So to find the curl f bar, we have the formula, and the equation is given as f bar is equals to x I bar minus y square j bar plus z cube k bar. So we know that f bar is equals to f1 I bar plus f2 j bar plus f3 k bar. When we compare these two equations, we get f1 as x and f2 as minus y square and f3 is z cube. So here the curl of a vector f bar is the formula is I bar, determinant of I bar, j bar, k bar, and the dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. That equals to, now substitute the values of f1, f2, f3 here. So that is I bar, j bar and k bar, dou by dou x, dou by dou y, dou by dou z, and x minus y square and the z cube. Now we have to find out the determinant of this. So curl f bar is equals to I bar, we delete this row and the column. So the remaining is dou by dou y into z cube minus dou by dou z of minus y square. And similarly here minus j bar, dou by dou x into x cube and dou by dou x of x, and plus k bar into dou by dou x of minus y square minus dou by dou y of x. So when we differentiate all this, I bar of z cube differentiation is 0, minus y square differentiation is 0, and minus j bar of z cube differentiation with respect to x is 0, and here also the differentiation becomes 0, plus k bar of 0 minus 0. The whole becomes 0. So we got the curl f bar as 0. Therefore the curl f bar is 0. And let's see the second question. If f bar is equals to x plus y plus 1 of I bar plus j bar minus of x plus y of k bar, then show that f bar dot curl f bar is equals to 0. So the given the f bar equation, the vector form of the f bar is given, and we have to prove that f bar dot curl f bar is equals to 0. So in this question we have the curl f bar. So first we have to find out the curl of the vector f bar. So f bar is equals to f1 I bar plus f2 j bar plus f3 k bar, we know this. So when we compare this equation, f1 is x plus y plus 1 and f2 is 1, that is a j bar coefficient, and f3 is minus of x plus y, which is minus x minus y. And the curl vector comes as I bar, j bar, k bar, and dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. That equals to the determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. And here the f1, f2, f3 values are x plus y plus 1 and 1 minus x minus y. Now we have to find out the determinant of this matrix. So here I bar of the, when we do the determinant, we get dou by dou y of minus x minus y minus dou by dou z of 1 minus j bar of dou by dou x of minus x minus y minus dou by dou z of x plus y plus 1, and plus k bar of dou by dou x of 1 minus dou by dou y of x plus y plus 1. That is I bar of, here the differentiation of minus y with respect to y is minus 1, and here the differentiation becomes 0 because since 1 is a constant, and minus j bar of, here minus x differentiation is minus 1 and minus y differentiation becomes 0, and in this term there is no z variable, so the whole differentiation becomes 0, plus k bar of constant differentiation is 0, and here 1 differentiation with respect to 1 is 1, and here the minus. So we get curl f bar is equals to minus I minus into minus plus j bar, and minus 1 into k bar is minus k bar. This is the curl f bar we got. But we have to prove that f bar dot curl f bar. So the f bar vector is x plus y plus 1 of I bar plus j bar minus of x plus y of k bar. This is the f bar vector, and dot product of curl f bar we got it as minus I bar plus j bar minus k bar. So when we are doing the dot product of the two vectors, I bar coefficient when we multiply, which is I bar dot I bar is 1, and I with j and k becomes 0. Similarly j with I and k becomes 0, and j with j becomes 1. So those properties we have seen in the LU classes. So that equals to, here the it multiplies with the coefficient of I bar. So x plus y plus 1, and the coefficient of I bar is minus 1, plus the coefficient of j is 1 and the coefficient of j is also 1. Then here plus of minus x plus y, which is a k bar coefficient, into the k bar coefficient is minus 1. Now we have to simplify this. So minus x minus 1 multiplies inside this, then we get minus x minus y minus 1, and here plus 1, and here the minus 1 into minus x is plus x, and minus y into minus 1 is plus y. So here minus x, minus y plus y, and minus 1 plus 1 get cancelled. So overall we get it as 0. So therefore the f bar dot curl f bar is equal to 0. Hence it is proved. Third question. Find curl f, where f bar is equals to x cube plus y cube plus 3 into xyz. So here we have as the, because it is a scalar point function, vectors. So let pi is equals to x cube plus y cube xyz, and f bar is equals to grade. So f bar is equals to grade pi, nothing but del pi. The formula is I bar dou pi by plus j bar dou pi dou y plus bar dou pi by dou z, and then here grade pi is to I bar dou by dou x of x cube plus y cube minus 3xyz plus j bar dou by dou y of x cube plus y cube plus z cube minus 3 into xyz plus k bar of dou by dou z of x cube plus y cube plus z cube minus 3 into xyz. Now we have to differentiate this with respect to x, y and z. So here we get f bar is equals to grade pi, that equals to I bar of x cube differentiation with respect to x is 3x square. And then here y cube plus z cube differentiation becomes 0. And in the term minus 3 into xyz, minus 3yz is constant and x differentiation with respect to x. So we get minus 3 into yz. Similarly here also we get plus j bar of 3y square minus 3 into xz plus k bar of 3 into z square minus into xy. So we know that this is a vector f bar which is a grade pi, and we know that f is equal to f1 I bar plus f2 j bar plus f3 k bar. Now we have to find out the curl of the vector bar. So here f1 is equals to 3x square minus 3yz and f2 is equals to 3y square minus 3xz and f3 is equals to 3z square minus 3 into xy. Now here the curl f bar is equals to I bar, determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z and f1, f2, f3. So that equals to determinant of I bar, j bar and k bar, dou by dou x, dou by dou y and the dou by dou z. Here the f1, f2, f3 values are 3x square minus 3yz and 3y square minus 3 into xz and here 3z square minus 3 into xy. So when we find out the determinant of this, we get the curl f bar. So curl f bar is equals to I bar, deleting this row and column, the remaining terms are dou y by dou y and dou by dou z, 3y square minus xz and 3z square minus 3xy. So when we find the determinant of this, we get dou by dou y of 3z square minus 3 into xy minus dou by dou z of 3 into y square minus 3xz. And here the minus j bar of relating this row and column. So we get dou by dou x of 3xz square minus 3 into xy minus dou by dou z of 3x square minus 3yz. Is k bar of dou by dou x of 3y square minus 3 into xz and dou by dou y of 3x square minus 3 into yz. So that equals to I bar of, here the 3z square differentiation becomes 0 and minus 3xy, minus 3x is constant, so y differentiation is 1. So we get 0 minus 3x and here minus 3y square differentiation becomes 0. In this minus 3x is constant and z differentiation become 1. So we get minus of minus 3x. And the same here also we get, here we get minus. So minus j bar of, here the 3z square differentiation is 0 and minus 3y is constant and x differentiation is 1. So we get 0 minus 3y and minus of 3x square differentiation is 0 minus 3yx yz, in that minus 3y is constant. So we get minus 3y plus k bar of 3y square differentiation is 0 minus 3xz differentiation is minus 3z and minus of minus 3x square differentiation is 0 and minus 3yz is minus 3z is constant. So we get minus 3z. That equals to I bar of minus 3x minus into minus plus 3x minus j bar of minus 3y and minus into minus plus 3y plus k bar of minus 3z minus into minus is plus into 3z. So that we get it as, here all terms will get cancelled and we get 0 I bar plus 0 minus 0 j bar plus 0 k bar, that is nothing but 0. So curl f bar we got it as 0. Therefore the curl of the gradient of pi is equals to 0. We have seen in the note point also, when the gradient of pi is given and when we find the curl of that gradient pi, so we get the answer as 0. And here is a final question on the curl of a vector, that is, prove that curl r bar is equals to 0. So let's take r bar is xi bar plus yj bar plus zk bar. So when they didn't mention the r bar vector, we had to take the r bar vector as xi bar plus yj bar plus zk bar. And r bar is equals to r1 I bar plus r2 j bar r plus r3 k bar, as we have written for the f bar vector. So here r1 nothing but I bar coefficient, that is x, and r2 is the j bar coefficient, which is y, and r3 is the k bar coefficient, which is z. So we got these r1, r2, r3 values. So curl r bar nothing but determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and x. This is r1 and r2, r3, nothing but x, y, and z. Now we have to find out the determinant of this, and we have to prove that the curl of the r bar vector is 0. So here is curl r bar is equals to I bar of dou by dou y of z minus dou by dou z of y minus j bar of dou by dou x of z minus dou by dou z of x plus k bar of dou by dou x of y minus dou by dou y of x. When we find the determinant of that, we get this. So here the differentiation of z with respect to y is 0 and differentiation of y with respect to z is also 0. So minus j bar of z differentiation with respect to x is also 0, and minus x differentiation with respect to z is also 0, and y differentiation with respect to x is 0, and x differentiation with respect to y is 0. So we get I bar of 0 minus j bar of 0 minus 0 plus k bar of 0 minus 0. So that is curl r bar is equals to 0. Hence it is proved.